Hello everyone, let's try and solve another problem. Evaluate the following limit or show that it does not exist. We have a limit as x and y approach 0 and 0 of the function 2xy divided by x squared plus 2y squared. Okay, some of these limits of higher dimensional functions, if the limit does not exist, sometimes it's easier to show that it does not exist than it is to prove that it does exist if the limit does exist. The first thing I'm thinking here is that, well, obviously it looks like a 0 over 0 type thing. The numerator approaches 0 and the denominator approaches 0. But depending on the rates at which x and y approach 0, we might be able to get something. We might be able to get we might be able to get different values for the limit. So one typical thing to do here to try and test whether the limit potentially might be undefined is to define a curve in the xy plane which goes through the origin and evaluate this function only on that curve, but then do that for different curves and see what happens as you approach the origin along different curves. That's what I'm going to start with to see if we can come up with an example that shows the limit does not exist, because if you approach along different curves and you end up approaching the origin and the function takes different values, then that's an indication that the limit does not exist. So that's what I'm going to start with, because it's not immediately clear to me for one reason or another that the limit does in fact exist. Yeah, okay. Well, let me write the function down first, or at least the limit we're trying to compute. And so what I'll do is I'll start with one curve, which I'll write down in parametric form. So x and y both equal t. I'll define the function f of t. Let's call this thing here. Let's call this g of x and y. So the idea here is it's like we're approaching the origin along the curve x equals y. Imagine we're kind of moving down this curve towards the origin. We want to look at what happens to the value of this function. Then f of t is equal to 2t squared divided by t squared plus 2t squared, which is clearly just 2 over 3. So in fact it's a constant. And now what I'll do is I'll define another curve and also another function. So now we'll evaluate the function at t and 2t. So this is like approaching the origin along this line. Okay, so h of t is equal to 2t times 2t, divided by t squared plus 2 times 2t squared. So what do we have here? 4t squared divided by t squared plus 8t squared. So this is 4 over 9. Which is different from f of t. So as we approach 0 along this curve, we'll end up with 2 over 3, because in fact the function is constant on that curve. But as we approach the origin on this curve, we end up at the value 4 over 9, because the function is going to be constant along that curve. And these are different values. So around the origin, this function doesn't It doesn't approach a single value as you approach the origin along different ways, and so the limit does not exist. Now, of course, this approach worked. It happened to work here. But if I had not been able to find multiple curves that end up giving different limits as we approach the origin, I mean, if the limit doesn't exist, there are curves where you'll approach different values, but that doesn't necessarily lead to a way of finding those curves. So if I were unable to find them, I'm not exactly sure what I would have done. I suppose I could have, cheated a little bit and gotten some numerical software out and plotted what this surface looks like and tried to just visually identify whether the limit exists or not. But this is a pretty standard thing to do, at least as sort of a first approach in evaluating these two-dimensional limits, or even higher dimensional. It doesn't have to be just two. If I find any mistakes in what I've done, or if I have any more thoughts, I'll put them into the description. Otherwise, thanks for watching.